Hello students, in the last class we learned about the functions, composition, and working principle of axial flow compressor components. Today, we will learn about axial flow compressor rotors. The axial compressor rotor is composed of rotor blades, impeller, drum shaft, and connecting parts. Its function is to drive the blades to work efficiently at a high speed, do work on the air, compress the air, and increase the air pressure. Compared with general compressors, the main feature of aviation compressors is high speed, which can reach thousands or tens of thousands of revolutions per minute. High speed can enable the compressor to obtain the required performance under the conditions of small size and light weight, and meet the most basic requirements of engine performance design, which is an advantage. However, under high-speed conditions, the rotor parts and their connections must withstand huge inertia, centrifugal force, aerodynamic force, torque, and complex vibration loads. If the part profile and force transmission scheme are not designed properly, there is a risk of destruction and damage during operation. If the centering scheme of the rotor parts and components is not appropriate, the rotor is improperly assembled. The balance is not good, and the lateral rigidity is insufficient. When the compressor is working at a high speed, the rotor will vibrate violently and affect the normal operation of the engine, which is a disadvantage. Therefore, the structural design of the axial flow compressor rotor has the following three requirements. First, it must be small in size, light in weight, simple in structure, and have good processability. Second, the rotor, parts, components, and their connections must be able to reliably bear loads and transmit force. Third, it must have good centering and balance as well as sufficient rigidity. Based on the above compressor rotor structure design requirements, there are three basic types of compressor rotor structures: drum type, disc type, and drum disc type. As shown in the figure, the first picture is a drum rotor, the second picture is a disc rotor, and the third picture is a drum disc rotor. Let's study them one by one. First, let's learn about drum rotors. The structure of a drum rotor is generally a cylindrical, olive-shaped, or conical drum connected to the front and rear half shafts by mounting edges and bolts. There are annular grooves, or longitudinal grooves, on the outer surface of the drum to install the rotor blades. The main loads acting on the rotor, such as centrifugal force, bending moment, and torque of the blades and drum, are all borne and transmitted by the drum. The advantages of the drum rotor are good bending, rigidity, and simple structure, but its ability to withstand centrifugal loads is poor, so it can only be used under conditions of low circumferential speed. Next, let's learn about the disc rotor. The disc rotor consists of a shaft and several discs, and the shaft connects the discs of each level into one. The disc edge has different forms of tongues and grooves for installing rotor blades. The centrifugal force of the rotor blades and discs is borne by the disc, and the bending rigidity of the rotor is guaranteed by the shaft. The advantage of the disc rotor is that it has a strong ability to withstand centrifugal loads, but its bending rigidity is poor. As shown in the figure, in order to improve the bending rigidity of the rotor, a distance ring is added between the disc edges in the disc rotor, and the diameter of the shaft is thickened. This type of rotor is called a reinforced disc rotor. Is there a rotor that has both good bending rigidity and strong ability to withstand centrifugal loads? It is the drum disc rotor we are going to learn about below. The drum disc rotor consists of several discs, a drum cylinder, and front and rear half shafts. The disc edge has different forms of tongues and grooves for installing rotor blades. Interstage connections can be made by welding radial pins, axial bolts, or tie rods. The centrifugal force of the rotor, blades, discs, and drums is borne by the discs and drums together, and the torque is transmitted to the discs and rotor blades step by step through the drums. The lateral rigidity of the rotor is guaranteed by the drums and connecting parts. Because the drum disc rotor has both the good bending rigidity of the drum rotor and the ability of the disc rotor to withstand large centrifugal loads, it is widely used on the high-pressure rotor of the twin rotor compressor. Students, in this class we have learned the three basic structural forms of axial flow compressor rotors. We must match the names of these three basic structural forms with the actual objects and master the structural characteristics, advantages, and disadvantages of each rotor form. Thank you everyone.